Okay, so let us take another topology and let us first say that this will be my OSPF area 0. This will be my OSPF area 1. And this will be my OSPF area 2. To OSPF area 1, this is multi-area OSPF. This is my backbone router. These two my area border routers, and these are normal routers in the other area. Just for trial purposes, I will simulate a loopback 1.1.1.1 on /32 on all the routers. 2.2.2.2, 2.2.2.2. This will be in area 0. This one will have 3.3.3.3. This will have 4.4.4.4. And this will have 5.5.5.5. As of now, we have 5 routers. Let us start. And basic IP addressing scheme will be 192.168.1.0/24, 1.0, 2.0, 3.0, and 4.0 /24. Here it is 2.0, 3.0. Okay, so let us start the very basic IP address assignment. Let us say so if you say that this is my router 1, this is the one that I want to configure. Enable configure terminal host name is router 1, and I will say interface gigabit 0/0 IP address 192.168.1.1, 255.255.255.0. No, shut it down. This is on. Let us create a loopback interface loopback 1 IP address 1.1.1.1, 255.255.255.255 exit. Okay. If you want to do the configuration right now, you can simply do it here also. Let us do it now itself. Enable configure terminal. Host name is router 1, interface gigabit 0/0 IP address 68.1.1. No shut exit interface loopback 1 IP address. No shut. How do you run a routing protocol over here? You will say router OSPF 1 network 192.168.1.0. match these 3 octets and put them in area 1. Understand one thing, that this interface is in area 1. This interface is also in area 1. 192.168, sorry, 1.1.1.1. Match these 4 octets and also put them in area 1. This is my basic configuration on router 1. Should we proceed? Let's say basic IP address assignment and routing protocol. Show IP OSPF interface. As of now, the interface is off. Technically, you can say loopback and internet addresses. Let us do the configuration of router 2 over here. Router 2 should have what configuration? If I say router 2 should have the host name of router 2, gigabit 0/1. Notice over here, gigabit 0/1 connects to 1.2 segment. So this will be 1.2. Loopback any number. I'll say 2.2.2.2. Router OSPF 1, 1.0, and here 2.2.2.2, and this is in area 1. But understand one thing, this interface of mine, yeah, this is okay, fine. This is the area 0's configuration, area 1's configuration. So let us go ahead and copy paste this configuration. Enable config t host name router 2. This router, his gigabit 0/1 has this IP address, so that they both are in the same network segment. No shut loopback 1, IP address 2222 as decided, and these 2 interfaces. Let us push the configuration on router 2. Simply say paste. Done. Show IP OSPF neighbor. We are initializing, we are in the init state. He is the DR other. Let us wait for a while and it should come up. Init, see down, attempt, init, two-way. It will come up sooner or later, no worries. Let us do the other configuration. What have we done till here? I think the neighborship came up. No. See, the neighborship took time, but neighborship comes up and I see the loopback of router 1 on my router 2. I have learned this route via OSPF. This is intra area actually. Intra means in the same area. Inter will come from another area. Let us say router 2. This router 2 will have one interface, gigabit 0/0 with this IP address. So first let us assign the IP address on gigabit 0/0. What will be the IP address? 2.1. No need of a loopback. We have already configured it. And router OSPF 1, I will say network 192.168. Sorry, I added 2.1 in here. This is correct. 2.0 match and put this in area 0. So what is the total configuration on router 2? He has two interfaces, loopback and this one in area 1 and this physical interface in OSPF area 0. Let us do that. Let us go on router 2, configure terminal. Show IP OSPF. See here, it will tell me that it is an area border router. Why? Because it has one interface. This interface is in area 1. This interface is in area 0. I am standing in the middle and that is why I am the area border router over here. And it will maintain two separate databases. One database for area 0 and one database for area 1. As of now, my area 0 is inactive. Why? Because there is no neighbor on area 0. Okay, let us save the configuration, copy and start. Let us do the config on router 3. What will be the config on router 3? Host name will be router 3, gigabit 0/0 will have this address, 2.2. Let us say interface, loopback 1, IP address 193.3.3.3, 255.255.255.255. And let us say exit router OSPF 1 network 3.3.3.3 match area 0. That is it. Let us do the config of this okay, let's do this first and then we'll move ahead. So enable config T. Sorry, it is router 3. Yeah, gigabit 0/0. 2.2 is the IP address over here. 2.1, 2.2 over here. Loopback 3 OSPF and this. Let us push this config on router 3 is a router 2. Don't be in a hurry. Let's go router 3. Show IP OSPF neighbor. It is initializing, it is coming up. It will form the adjacency. Init to a down, attempt init two-way, start exchange. Loading and done. It will come up soon. If you want to check show IP OSPF database, it is as of now LSA 1 because the neighborship has not come up. Once you have the database exchange, you will see multiple LSAs inside it. Loading is coming up. Now, if you see after I am done with the exchange, I will be able to see, okay, this is my LSA type 1, link state advertisement type 1. This is sent by the routers in the area. This is the DR on the segment and this is the summary by the ABR. Let us go and configure router 3's gigabit 0/1, assign it an IP address and put this in area 0. Let's go there and say gigabit 0/1, if I'm not wrong, yeah. This has the IP address of 3.1 as decided, 3.1. No loopback needed as of now. Router OSPF 3.0. So what did I do? I just told this router 3, this interface has this address, and OSPF, please advertise, please start sending hellos on the interface that has this address. Let's go and do that. Let's say Control C. Let's go on this router 3. This is router 1, sorry. Router 3. Let's see, enable configure terminal router 3. Show IP OSPF interface. It will tell me it is as of now gigabit 0/0. Why? Because there is the neighborship, this is off. Let us write the config of your router 3. Sorry, router 4 now. We will write the config of this router, who is router 4 over here. This is gigabit 0/0. This is 3.2. 3.0, perfect. And let us create a loopback also. Interface loopback. 1 IP address 3.3.3.3 match. Sorry, no shut is not required. Exit is there. And let us put this one in 0.0.0.0 in area 0. Getting the point? So this is the config of router 4. He has this gigabit interface with this IP address. He has a loopback virtual interface 1, 2, 3, 4. It should be 4.4.4.4. As decided earlier, this will be 4.4.4.4. And here I was wrong, 4.4.4. So always be double sure before doing the configuration. Let us copy this configuration and paste it on router 4 over here. Let us say you have an interface and an IP address. So IP OSPF neighbor. It is initializing, means we have discovered a neighbor. What we will do is, we'll do something interesting. We'll not take this as area 2. Okay, we'll do multi-area first. Then what we can do is, we can also run RIP, another routing protocol over here. A router that has one interface. So instead, if I say, instead of this, I want to run RIP. I don't want OSPF. I want to run RIP version 2. A router that has this router, you can say a router that has one interface in OSPF, another interface in another routing protocol is known as your Autonomous System Boundary Router, ASBR. There is a small function that he has to perform called redistribution. By default, these two routing protocols will not communicate with each other. But as far as this point is concerned, we have configured all our routers. We have configured this router, this router, this router, and this router with OSPF areas. Now what we will do is, we will first test. We will first make sure that this router over here, can he see the routes 4444? Let us see, let us go on router 1. Let us go on router 1. Can I see? Show IP route. Can he see 4.4.4.4 over here? Right? Can I ping 4.4.4.4? Yes. So my connectivity from my router 1 till router 4 has been established. Assuming a scenario wherein there was a merger and these people here do not want to run OSPF. They say we like RIP and we will run RIP only. So this router over here has one interface in OSPF. Here we will assign the basic IP address and we will run RIP between these two routers. Let's do that. Let's say we go on router. What will be the configuration? This is my RIP router. Let's write the plain new configuration. Let's say this will be enable configure terminal interface gigabit 0/1 IP address 192, let's say 192.168 dot, what is 4.0, right? So 4.1, no shut, and let us say exit, let's say router RIP version 2, no automatic summarization, and network 192.168.4.0, simple as that. Here, this router 4 is going to run RIP over here on this interface. Why? Because the network command says you have to advertise your routing table on this one if you have all those in your RIP. Let's do that. Let's go on this in router, and let's say this is my router 4, for example, this one. Let's say configure terminal. Let's give it an IP address. I said 0/1 4.1. This is, so this router show IP OSPF. As of now, OSPF will not declare itself as the ASBR, Autonomous System Boundary Router. Why? Because he is still lagging. He has to do a small function, that is to take this routing protocol and mix it in this routing protocol. Let us complete our configuration. Let us see what will be the config of your router R1. Can you see my screen? Okay, let's write the configuration of your router 5. Enable configure terminal. Interface, sorry, first do the naming ceremony. R5 interface gigabit 0/0 IP address 192.168.4.2. What is the command to check your directly connected neighbors IP address? You can say show CDP neighbors detail, but I'll tell you more about that later on. And let us simulate a loopback interface. Let us give it an IP address 5.5.5.5. Now here I am running RIP network 192.168.4.0 and network 5.0. Even though if I say 5550, he will say 55000/8. Let us do the basic configuration of RIP on router 5. Let's go on here and let's say router 5, Mr. Router 5, please take the configuration and show IP route. This is by default show IP protocol. It is running. It will take around 30 seconds. As of now, it is directly connected, no problem. Let's go on this router and check whether he is receiving a route. Do I see routes received via RIP 5555? So this guy over here is getting the routes of 5.5.5.5. Why? Because he is running RIP over here. But is this router or this router or this router getting the routes of 5.5.5.5? Let us check. Let us go on this router. Is he receiving the route? Show IP route. Am I receiving any route about 5555? No. Why? Because even though this router is receiving the route 5555, he is not advertising this route into OSPF. He is not taking the route from this domain and putting it over here. By default, two routing protocols. See, OSPF area 1 and area 2 were communicating, but RIP and OSPF will not communicate until and unless you do not do a small feature, do not do something. So what we are talking about here is, I am saying that I want to take this router. I am saying that RIP, this router, Mr. Router 4, take RIP and put it in OSPF, and OSPF put it in RIP. But understand one thing, RIP and OSPF both have a different language of love, right? Because OSPF understands link bandwidth, RIP understands hop count. How will they understand each other, right? So we have to tell them. Let us see, and OSPF is class less, RIP was class full. Let's do that. Let's say router RIP, and here I will say please redistribute OSPF1, and while redistributing you have to say the metric. If you had a serial link, actually OSPF calculates the link's bandwidth by it should be 10 raised to 7 or 8 divided 100 Mbps divided by the actual bandwidth. If it is a serial link, the cost will be 64, and if OSPF puts the cost as 64 over here, RIP will say I do not support more than 15 hops. It does not take it. So what we will do here is we will say redistribute OSPF1 and metric 1. This is known as seed metric. The moment RIP takes routes from OSPF, he will add a metric of 1. Let's do the same thing. Let's say router OSPF1, please redistribute RIP, and please take the subnets also. If you forget these keywords, only class full networks will be redistributed. The subnets keyword is very important over here. As of now, I did a small function of redistribution. I said on the ASBR, always be sure you do it on the router that has this. Don't do it over here. It will be of no use over here, no use. The router that is the ASBR has to do this, right? So on this router, I went inside and I said, router, I should be in the global configuration mode. I said router OSPF, the process ID, redistribute RIP subnets, and I said router RIP, order of operation does not matter, redistribute OSPF1, seed metric is 1. This is what we did. Now, after doing that, if you say show IP OSPF, let us do that. Let us go on your router 4 and let's say show IP OSPF. Earlier when we did show IP OSPF, does it say I am the ASBR? No, right? But if I say now, if I say show IP OSPF, it says I am the autonomous system boundary router. Why? Because he is the one who is doing redistribution. And if you notice now, if I go on these routers or this router, earlier this router was not able to see OSPF routes, right? 5.5.5.5. Now, do you see something different in here? This guy receives a route OSPF external type 2 route, external type 2 route, that is external type 1 and type 2. As of now, the metric will be 20 only. He will receive this route from another domain. This is not from OSPF. This OIA means it is OSPF another area. OE2 means it is OSPF external type 2 route. See, I will go on router 1. Final thing is just to check show IP route. Can I receive a route over here? R1 has successfully received the route of R5. This is coming from this domain over here into OSPF, from OSPF area 0 to OSPF ABR, and from here to here. This is the router that will generate the LSA type 5. If you notice in here, I will go on any other router. Show IP OSPF database. See now LSA counts increases. Type 1, type 2, type 3, type 5. Type 4 is missing, but type 5 is the external link states, is generated by the ASBR, Autonomous System Boundary Router. Getting the point? Here, if you want, you can also create a very amazing thing. You can also create a tunnel from here. That I'll show you later on. But what we can do is we can create a GRE tunnel from here. Assuming that you have 2 offices and you want to create a tunnel from here to here. Your underlay network will be physical. Your overlay network will be logical. You will feel that this guy connects to this guy with 1 hop count away. You can also do that. Let me show you that and we'll practice after this. But as of now, let's stop here. Let's stop here and then we will continue with GRE tunnel. What we will do is we will form a simple generic routing encapsulation, a GRE tunnel over this physical network.